In this video, we'll write code to control a continuous rotation servo. Unlike a standard servo, which usually turns only about 180 degrees, a continuous rotation servo can keep spinning, which makes it useful for driving small vehicles. The servo model we're using in this video is an FS90R and is built by VTech. With a continuous rotation servo, the code does not control the angle of the servo. Instead, it tells the servo which direction to turn and when to stop. Let's start by looking at the setup of the microbit. Okay, this microbit has the servo attached, but let's go ahead and unplug the servo. And you can see that it has 3 female connectors, one for each of these wires. On the microbit, we have 3 alligator clips, one on pin 0, one on the 3 volt, and one on ground. And these have male connectors on the other end. Most servos have 3 wires and each is a different color. Usually they are either black, red, and white, or as in our case, they're brown, red, and yellow or orange. The brown wire goes to ground, the red wire goes to the power source, and the yellow wire is our communication wire. So I'm going to connect this back up, and so I'm going to take the ground wire on the microbit, which is blue, and connect that up to the brown wire on the servo. The red wire on the microbit is connected to power, and I'm going to go ahead and connect that to power on the servo, which is red as well. And then finally, I'll connect to the communication pin, which we're going to be using pin 0, to the yellow wire on the end, which is the communication wire for the servo. Now let's go to MakeCode and write the code for the movement. I'll set it up using the buttons to control the motion. Button A will cause the servo to turn counterclockwise, button B will cause it to turn clockwise, and when buttons A and B are pressed at the same time, it will make them stop. I don't need the on start or the forever block, so I'm going to drag those to the trash. Then I'll go into input and click on button A pressed, and that'll put a copy on our screen. Next, I want to go to Advanced, scroll down until I see Pins, click on that, and then scroll down until I find Servo Right Pin, and drag that into the On button A pressed. This block is usually used to set the angle of a standard servo, but with a continuous rotation servo, the numbers work differently. Instead of setting the angle, it controls the direction of rotation, or it tells the servo to stop. So if we set this to 180, it's going to tell the servo to turn counterclockwise. If we set it to 0, it'll tell the servo to turn clockwise. And finally, if we set it to 90, it'll tell the servo to stop turning. So we will leave it at 180 because we want button A to turn the servo counterclockwise. And we are using pin 0, so we'll leave this set at P0. Now I'll duplicate this. And we'll change the A to a B, and then 180 to 0. Now B should make it turn clockwise. Now we'll duplicate it again, and we'll change the A to A plus B, and then change the 180 to 90. So when we press A and B together, it should tell the microbit to stop turning. We can't test the continuous rotation on the simulator because it's only set up to simulate a standard servo, but we can at least test that to make sure we have everything set up correctly. So I'm going to go ahead and click on the A button, and that turns it counterclockwise to 180. When I click B, it turns it clockwise to 0. And then when I click the A plus B button that the simulator added, that turns it to 90. Now we can test this on our microbit. A servo is a physical motor, and each motor will have small mechanical and electrical differences. So it may not respond perfectly to the exact number that the code uses to signal stop. So in our simulator, we set that to 90, and that means stop exactly. But on a real servo, you may need to adjust the trim screw so that the physical motor actually stops when the code sends the value of 90. So trimming means to adjust the servo's trim screw, which is located on the bottom of the microbit, so that the motor stops completely when signaled to stop. Now let's test it on our servo. Okay, I'm going to press the A button on the microbit, and we can see that makes it turn counterclockwise. I'll press the B button, and it turns clockwise. And now I'll press A and B together, and we can see it's still turning. Okay, I'm going to take a screwdriver here, and this is a flathead screwdriver. The screw actually takes a Phillips head, and if you have one available, that's great, but this is going to work. So I'm going to go ahead and turn this slightly. Oh, that speeds it up. I'll turn it the other way, and that stopped it. So I just turned it a little bit and got it to stop. Now let's go ahead and test it again. It's turning counterclockwise. Now it's turning clockwise, and now it stops. So that's it for this video. If you like it, please give it a thumbs up and subscribe to my channel. Thanks for watching.